Okay, so now we're on the 7.2 notes, and our learning target for 7.2 is that we will be using the Pythagorean theorem converse to determine if a triangle is a right triangle. So if you remember Pythagorean theorem from 7.1, Pythagorean theorem says that if a triangle is a right triangle, then that means that you can square the two legs and add them together, and it will equal the hypotenuse squared. The converse of the Pythagorean theorem is flipping the hypothesis and the conclusion. So the converse says that if a squared plus b squared equals c squared, then the triangle is a right triangle. Okay, so here's the definition of the Pythagorean theorem converse, which I was just talking about, where we switched the hypothesis and the conclusion. So it says that if the square of the longest side equals the sum of the squares of the other two sides, then it's a right triangle. In other words, if we want to put it simply in formula form, c squared equals a squared plus b squared. So go ahead and pause the video if you haven't gotten all of that written down yet, and write that down in your notes. Okay, so now we want to use the converse of the Pythagorean theorem to decide whether the given side lengths make a right triangle. And you need to look at the list of your side lengths first and note what the longest side is. This side has to be set up as c squared, or as c, but we will square it. So we need to set this up as the longest side squared, and c if it is equal to the sum of the two shorter sides when they are squared. Okay? So you can go ahead and use your calculator to do this. You can just type into your calculator as this is written, 15 squared plus 36 squared. You don't have to do anything fancy. You can just type that in as is. And you can also then type in 39 squared, and you should get these numbers. And these added up also equal 1521. So that tells us that it is a right triangle, since a squared plus b squared did equal c squared. Okay, on this next problem, things get a little trickier. These are not nice, pretty whole numbers, so we can't just glance at them and know what the longest side length is. So you have two options. If you feel confident in estimating a square root, you can estimate the square root of 11. And the way to do that is to base it on the fact that 11 is between two perfect squares that we already know. 11 is between 9, which we know the square root of 9 is 3, and 16, which we know the square root of 16 is 4. Okay? So that allows us to estimate that 11, or the square root of 11, is somewhere in between 3 and 4. Okay? If what I just said didn't make any sense at all, the alternative is to type the square root of 11 into your calculator and have your calculator give you an estimate of what it is. You can also estimate 2 times the square root of 7 by first estimating the square root of 7. So the square root of 7 is somewhere between the square root of 4, that's a perfect square smaller than 7, and the square root of 9. Those are the two closest perfect squares to 7. So 7 is somewhere between 2 and 3, and 2 times the square root of 7 is somewhere between 4 and 6. So what's the biggest number here? Well, if the square root of, or if 2 times the square root of 7 is between 4 and 6, and this is 4, and 11 is somewhere between 3 and 4, this is actually listed from smallest to largest. So the biggest number here is 2 root 7, and that's what we're going to set up as our hypotenuse. Okay, so you are welcome to use your calculator, but you also don't need to use your calculator. So we'll set this up again as what side we think the hypotenuse would be if it were a right triangle, squared, equals the other two sides that would be the legs, squared. And if you are using your calculator, You absolutely need to either put this in parentheses. Well, you definitely need to put it in parentheses, but then you also need to arrow over to get out of the square root if you have a newer calculator. You also do not need to do this in your calculator if you don't want to. The way to do 2 square root of 7 squared is to square the 2, which is 4, and square the square root of 7, which is 7. So that's 4 times 7, which is 28. Okay, so there's 2 root 7 squared. And if you do this on your calculator, you should also get 28. If you get 14, you did something wrong. You need to go back and put parentheses in. Squaring the square root of 11, if you square a square root, it cancels it out. So the square root of 11 squared is 11, and 4 squared is 16. Okay, so is this true? Does 11 plus 16 equal 28? No, it doesn't. It equals 27. So this is not a right triangle. So I want you to take a moment now to pause the video and see if you can do the next 2 on your own. You need to decide what the longest side is, and you need to square them. You can use your calculator, or you cannot use your calculator. Alright, so you should have set this up with 8 being the longest side, so 8 squared equals the 2 smaller sides squared and added together. Gives you 64 plus 16 plus 48, which, yes, that is true. If for 4 root 3 you got something like 12, you need to go back and double check what you did. These are easier. They're just integers, so you can just type them into your calculator or even do them in your head. You may know that 14 squared is 196. If you don't, maybe try to familiarize yourself with those perfect squares. 10 squared is 100 and 11 squared is 121. When you add these up, you get 221. That is not equal to 196. You can say, no, this is not a right triangle.